Welcome to your essential guide for the Dubai Municipality G+4 exam for civil engineers. This session will provide you with a quick and comprehensive overview of the exam. We'll cover the most tested construction topics: reinforcement, concrete, foundations, testing, and post-tensioning, using Dubai Municipality standards. Focus especially on local requirements like cover values, pile testing percentages, and hot weather precautions. These are critical for both safety and exam success. Let's begin with reinforcement, a core structural component. The lap length, which ensures bar continuity, is standardized in Dubai at 40 times the diameter of the bar in tension zones. For example, a 20 mm bar needs an 800 mm lap. Minimum longitudinal reinforcement must be 1% of the gross cross-sectional area. In circular columns, we require at least 6 bars for uniform load distribution and ductility. Now, cover is very important for corrosion protection in superstructures. We need 30 mm. For substructures cast on blinding, 50 mm, and directly on soil, 75 mm. Circular columns need at least 40 mm. The spacing of stirrups or ties ensures confinement. The spacing must be the smallest of 16 times bar diameter, 48 times tie diameter, or the column's least dimension. Concrete strength is central to design. Structural elements require at least 35 Newton per square millimeter cube strength, or 28 Newton per square millimeter cylinder strength. These are the DM's minimum thresholds. For non-structural elements, blinding layers need 20 Newton/m squared. Precast units demand at least 40 Newton per square millimeter due to handling stress. A general purpose mix uses a 1:2:4 ratio, cement sand aggregate. However, more important is the water cement ratio, which greatly affects strength and durability. Concrete gains around 70% of its strength in 7 days and reaches full design strength by 28 days. Testing is typically done at this 28-day mark. Post-tension concrete is used for longer spans and slab thickness optimization. In Dubai, PT slabs must be at least 200 mm thick. The tendons used are high-strength steel cables with 1,860 megapascals capacity. The jacking force applied must not exceed 80% of this capacity to ensure safety. Also, tendons must be placed no farther than 0.5 times slab thickness from the column face to maintain slab integrity. The required precompression force in two-way slabs is 0.9 Newton per square millimeter. This resists tensile stresses. Grouting should be shrinkage compensated and must match the concrete strength at 28 days. Formwork removal, curing, and construction joints play a significant role in construction. For footings and mass concrete, it's safe after 24 to 48 hours. For slabs up to 4.5 meters, props should remain in place for 7 days after formwork is stripped. Construction joints allow for scheduled halts in concrete pours. They're planned in advance to prevent weak planes in structural load paths. In Dubai's hot climate, curing is critical to avoid rapid moisture loss and plastic shrinkage cracks. Always cure slabs and columns using water or curing compounds. Honeycombing is another common issue caused by poor compaction or insufficient vibration, leading to visible voids in the concrete. Load cases and reinforcement are essential for structural design. The Dubai Municipality relies heavily on ACI 318-19 for load combinations. 1.2D plus 1.6 liters is the standard load case. Snow isn't common here, but in cold zones, it's 1.2D plus 1.0 liters plus 0.5 slets. Revised structural formulas for simply supported beams: M equals WL squared, 8 for fixed end beams, M equals WL squared, 12. This helps evaluate maximum bending moments for design. Beams can have max 4% reinforcement of gross area to ensure ductility. Slabs must have at least 0.0018 times gross area in flexural steel, and shear links should be spaced at D/2 max. Columns are designed for axial stress equals load area. This is often asked in calculation-based questions. The main types of footings are isolated, strip, combined, and raft, mat. The choice of footing type depends on the building's load and the soil conditions at the site. For circular footings, use both radial and ring-shaped reinforcement to distribute loads evenly. Shear keys are small projections under footings that help prevent sliding, especially in areas with lateral loads like wind or seismic zones. Key requirements: use minimum 12 mm rebar in piles, ensure 95% compaction in backfill in seismic zones. Pile foundations are preferred for better stability. Piles are used when surface soil is weak. Types include end bearing, load transfer deep, friction, resistance along shaft, tension/uplift, counter upward forces. Pile spacing should be between 2.5 to 3.5 pile diameter for proper load distribution. Testing is mandatory in Dubai: 2% static load test, actual load check, 3% dynamic load test, quick method, 100% integrity test, detects cracks/voids. Soil investigation determines the type and strength of foundation. Key classification tests: Atterberg limits, plasticity index of clays, sieve analysis, grain size distribution. Compaction testing like the Proctor test identifies the optimum moisture for max density. Strength tests: unconfined compression. For cohesive soils, triaxial and direct shear, give friction and cohesion values. Bearing capacity is assessed using plate load test, actual foundation simulation (SPT), standard penetration test (CBR), California bearing ratio for pavements. Concrete properties and testing are essential for quality assurance. Fresh concrete slump test, workability, 25 to 50 mm for mass concrete. Problems like bleeding or segregation indicate poor mix. Hardened concrete creep, long-term deformation under sustained loads. Modulus of elasticity, measures stiffness, E equals Fc to the power of 0.5 times constant. Testing methods: compressive test, cube, main strength check at 28 days. Split tensile test, reveals tensile behavior. Rebound hammer, surface hardness, non-destructive, UPV, pulse velocity test for crack detection. Construction management requires clear accountability. Contractor responsibilities: execute per specs and drawings, ensure QC of materials and workmanship, maintain safety and regulatory compliance. Engineer responsibilities: review materials and shop drawings, approve site modifications, inspect and ensure compliance. Essential documentation includes test certificates, permits, trade licenses, and approved drawings. In summary, focus on key site topics like deshuttering times, concrete strength classes, mix ratios, and pile-related questions. These are commonly tested in the Dubai G+4 exam. Also, practice calculation-based questions such as bending moment, shear force, and basic stress formulas, as they often appear in practical MCQs. Thanks for your time and focus. We wish you the best of luck in your exam preparations. For any questions, feel free to connect with us at contact@xiapi.com. Don't forget to download sample MCQs for better preparation.